Hi, welcome to the session by RouteFabric, and in today's session we're going to be covering object-oriented programming in Java. Alright, so the plan for today is first we're going to discuss object-oriented programming in a general context. Then we're going to talk about the three principles of object-oriented programming. Then we're going to get into object-oriented programming in Java. And then finally, we're going to dive into some code. And this is going to be a longer lesson than usual, so it's most likely going to be split up to where the code is in a separate video. All right, so first we have to answer what is object-oriented programming. So really, object-oriented programming is a method of problem solving that quantifies real-world ideas into distinct objects. So when we're trying to solve a problem with our programming, when we do object-oriented programming, we want to try to split that problem up into tangible objects that we'll encounter. So if we have like, for example, a hotel, you could have like a room object, you could have a patron object, you could have like a front desk object, that kind of thing. So traditionally in functional programming, data and functions are separate. So we've already looked at this. Our methods are distinctly different from our data. So we have our variables, and then we also have our methods, and those are kind of put apart from each other, and our methods can act on our data, but they're never really put into the same thing. Well, with objects, objects have both data relating to them and functions relating to them. So this is meant to kind of mimic real life. So, as a person, I can have data relating to me, like my height, my age, the color of my hair, stuff like that. But then I can also have functions relating to me. So I can eat, I can run, I can jog, I can go to work, those kind of things. So I have both data relating to me and functions relating to me. So basically, in short, objects can both know things and objects can do things. So how do we actually implement object-oriented programming? So first, we have to identify which objects exist in a problem. So if we're giving a problem we need to solve and we need to write a program to solve this problem, we need to actually find out, okay, which individual objects can I see in this problem? So if we go back to kind of the hotel example, you could say, okay, well, I see a room object, and then I see a person object, and we can assign a person to a room, or we can assign multiple people to a room, that kind of thing. So also keep in mind, we only need to identify objects that are relevant. We don't need to make absolutely every single object. So for example, with our hotel problem, we wouldn't necessarily need to make a lamp object or a bed object. Maybe those aren't relevant if all we're trying to do is just manage the finances of that hotel. Then we would only need a person object and then maybe a room object, that kind of thing. But we wouldn't need to make objects for absolutely everything. So we only need to identify objects that are actually relevant, and then we only need to include functions and data in that object that we will actually use. So for example, if we have a room or something, we would want to include the price of that room. That would be relevant for our finances, but we wouldn't really need to include the color of the paint in that room. We don't need the color of the wallpaper. That's not really relevant, so we can leave that data out. We don't have to include absolutely everything. All right, so once we identify which objects exist in the problem, then we can create classes. So basically, classes define a type for us. So they act as a specification for objects. When we write a class, what we're really doing is defining our own type. We're defining our own object, and we're saying, hey, this is what goes into the object. This object has this property, and it has this property, and it has this function. So the class is really our definition for our objects. As discussed earlier, all code in Java exists within a class. This is mandatory. You can't have free-floating code outside of a class. So this means that a class does not necessarily need to describe an object. So we'll get into this when we look at static. Basically, all I'm trying to say here is that if we write a class, we don't necessarily need it to define an object, but a class is often used as a definition for an object. So next we can create specific instantiations of our class, and these are called objects. So our class is like a definition for what our objects are going to be, and then we can create specific instantiations of that class, and those are going to be our objects. So we can define a class once, and then we can create 10 objects from that class. So for example, we can define a person class, and we can say, okay, a person has a name, they have a hair color, they have a height, and then we can create person 1, name him John. We can create person 2, name her Jane, that kind of thing. So also, just a little note again, we don't necessarily need to instantiate our class to use its methods or data, and this is especially true in Java because everything in Java must be within a class, so therefore we don't want to instantiate all of our classes. So you'll very often see in Java classes that are not instantiated. All right, so what? Why do we actually care about object-oriented programming? Well, object-oriented programming offers many benefits to us. So the first benefit it offers is abstraction. So what this means is that we don't need to see or know the inner workings of an object to use them. We can just use them, and we demonstrate this all the time. We can use something like a java.util.arraylist without necessarily knowing how that array list works. So if you were to ask someone, hey, what's the inner workings of array list? What are all its methods? What are all its variables? How does it allocate memory? We don't need to know all that just to use the array list. We can just use it. We also get a benefit of modularity. So the same class can instantiate multiple objects, and then we can use the same class in many different projects. So our classes are kind of modular. So we can use an array list in our project, or if we create a project in the future, we can use an array list again. Or for example, we can use system.out in a lot of different places. You can use that in a multitude of projects. Object-oriented programming also offers great portability because the same classes can be used on many different systems. So we can use our class, on a system we use for our phone, or maybe one that we use for our computer. So we can define the same classes and then we can use them in many different places. Think about system.out.print. This is a method, of course, but this is very portable. We can use this on our systems, or we can use it on our friends' systems, or we can go to the university and use it on their computers. Really, anywhere the JVM is present, we can use our classes. So of course, object-oriented programming also offers great scalability. So what this means is that as our projects grow larger and larger, we can simply create more classes and instantiate more objects. And so we can kind of keep parts of our projects kind of away from each other. So we can have classes that deal with the technical details like the logic, and then we can have classes that deal with, say, the graphical user interface, and then we can have classes that deal with, say, internet interfacing, that kind of thing. And we can have classes that deal with the file manipulation. So we can kind of keep everything separate. And this is great too, because we can also even use the same names. So we can have a class that has a member called name, and then we can have a different class that has the same member called name, and those are different, and you're not going to confuse your program. So this allows our program to, or I'm sorry, our project to scale up really well because we can create more and more things and add more and more things to our program without jumbling it up and without creating kind of this spaghetti monster where this goes over there and this is linked to here and this is over here, but it gets confused because these things have the same name. That's not really much of a problem with object-oriented programming because we can separate our projects into distinct modules. And these benefits can be further expanded upon when we get into more complex topics like inheritance, polymorphism, and also generics in Java. Once we get to these topics, we can really see these benefits in play even more. All right, so the three corners of object-oriented programming. So there are three main concepts that we need to understand that are absolutely essential to object-oriented programming. So those three concepts are encapsulation, inheritance, and polymorphism. So inheritance and polymorphism will go hand in hand. They go hand in hand with each other, and this will be covered later. So I'll just give kind of a quick overview here. Those are a little bit more complicated, and in order to get those down, we really need to understand encapsulation first before we can get to inheritance and polymorphism. So I'll just quickly touch on them here. All right, so encapsulation. So encapsulation refers to encapsulating data and functions into a class. So as we said, an object can both know things and do things. So when we say encapsulation, all we're really saying is put the relevant functions and relevant data into our objects and encapsulate them within our class. So we want to make sure we put things in the right places, basically, and that we don't put methods that are pertaining to a specific object outside of that class. All right, so inheritance refers to having classes built on top of other classes. In Java, we use this with the word extends. Like I said, we'll get into this more in depth later. Just a quick little example. You can say that a dog is a type of animal, And then an animal is a type of organism, and then an organism is a type of entity. So we can say, okay, class dog extends animal, which extends organism, which extends entity. So you can see how inheritance works there. So we have entity, and then entity as a child, which is organism. Then organism has a child called animal, and then animal has a child called dog. And then we can go even further than that, and then like dog can have a a child called like poodle, that kind of thing. So polymorphism quite literally translates into many forms. So what this means is that the same underlying object can take many forms and do different things with the same exact action. So again, I'm just going to touch on this real quick. An example of this would be like a person can be a student, a father, and an employee. So we have one class here, we have one thing which is a person, but really this person can be multiple different things and they can all do the same function, work. So let's say as a student, work means studying, and then as a father, work means looking after the kids. And as an employee, maybe work means filling out a spreadsheet. So you can see how we have really one object here, but it takes many different forms, and it can do different things with the same exact function. So this is kind of the idea behind polymorphism. All right, so let's get in depth into encapsulation because this is the main one we want to focus on for now. So as stated, we need to identify different objects in our problem and then decide what functions and data pertains to that object. So then what we need to do is we need to encapsulate these functions and data into that object. So this is what encapsulation is really all about. And so we need to make wise decisions about who owns what data and who does what actions. So when we're encapsulating, we want to make sure we kind of put things in the right place. So if we have a person, say we have like a person class, that kind of thing, and we have a function walk, it would make sense to encapsulate walk into the person class because a person is the one who's going to be walking. Let's say we have a sidewalk class. We wouldn't really want to put walk in the sidewalk because if we think about it, the sidewalk isn't the one who's walking, it's the person. So when we're encapsulating, it's really all about deciding where to put things and putting all the relevant details of a class into that class and not putting it outside of that class. This also means putting functionality that our classes will have in that specific class, not in main. So if we have like a store class or something and we want the store to run, we'd want to make that pertain to the actual store. We wouldn't want to write that code in main because that's not really encapsulating what a store does. So for example, let's say we have a laundromat program. So we're thinking about a laundromat and we see, okay, what objects do we have in a laundromat? Maybe we have a patron object, maybe we have a washing machine objects, and maybe we actually have a store object for the laundromat. So who does the washing? Does the person wash or does the laundry machine wash? So where do we include a wash function? And you can really make arguments for either here, but this is kind of illustrating what encapsulation is all about. You want to make sure you put your functions and your data in the right classes and you encapsulate them within that class. So we wouldn't want to write a wash method in our class where main is, because that doesn't make any sense, because either the person's going to be washing or the washing machine is going to be washing. Either one of those, we can make an argument for either, but that's who is actually going to be doing the washing. That's not going to be done um, in main. So we want to make sure we encapsulate our functions and data in the right places. So as I just stated, we don't want to put functions and data in random places or in main when they really belong to an object. All right. So designing classes. So when we write a class, we want to encapsulate what our objects will do. Keep in mind, we only need to include relevant information and function. So if something is not relevant to our specific program, if we don't need that functionality yet or ever, don't include it. We just don't need to include extra code that we don't need. So there are many different ways we can choose to design our classes. So some classes are designed as immutable. So this means they are unchangeable. So if we design a class to be immutable, this means once that class is instantiated into an object, that object can't later be changed. So we can create kind of an initial state of that object, and then it's going to stay that way. If we want to change it, we'll have to create another object because we can't actually change that object because it's immutable. So this is kind of one way we can design our classes. Some classes are designed to be mutable, in other words, changeable. So if we have a class that's mutable, we can create an object, and then we can later change that object. So let's say we have like a person class. If we instantiate a person object, we wouldn't really want to change that person's name, right? Because a person's name generally doesn't change. They keep that same name their whole life. So maybe we'd want to design person to be kind of immutable because we don't want to change the person's height or the person's age or the person's name in the lifespan of our program. So maybe we'd want to design that is as immutable. But then let's say we have something like a washing machine object. Maybe we'd want to design that as mutable because we can change the state of a washing machine. We can change the washing machine to be in use, or we can change it to be free, or we can change the washing machine to be broken. So maybe we'd want to design that as mutable. Some classes are designed to only be instantiated once. This is what's known as a singleton class design. I won't get too in depth with this, just know that this is a design choice you can use. If you want a class that you only want to create one object out of, you can designate it as a singleton class. We can also use access modifiers to expertly craft our classes to limit how much info the user can access and exactly how it's accessed. So this keeps our classes safe and allows us to abstract away parts of our classes, which basically means we're dumbing down our class so the user can't break them. So if we have something that is essential to how our class works and we don't want that to be changed, or we only want it to be changed by our class, then we can use access modifiers to achieve that functionality so our user can't destroy our class. All right, so object-oriented programming in Java. Again, everything in Java must be in a class. So in order to access methods or data without instantiating an object, we use the static keyword. We'll get into this in just a second. Basically, just know here that whenever you are, since everything in Java needs to be within a class, often you'll find this scenario where you have a class, but you don't want to instantiate it, and then that's where static comes in. Classes also have these special methods. They're kind of methods, and they're called constructors, which are called upon object creation. I'll get into depth in these in a little bit as well. So just a little side note, if you're coming from another language, keep in mind there are no destructors in Java. So the reason there's no destructors in Java is because of the Java garbage collector. So because of the garbage collector, we can't predict when or even if an object will be destroyed, and as such, we can't reliably execute a destructor. So if you're looking for a destructor kind of functionality in Java, just know that doesn't exist. The reason being is we don't know when our objects are going to be destroyed, so we cannot specify a destructor. Classes also have access modifiers, and these are going to be private, public, or protected. So just a quick overview is public allows member access outside of the class, private does not. So this is what allows us to abstract away parts of our classes. And we'll get into protected later because it's not relevant unless you're dealing with polymorphism and inheritance. That's where protected comes into play. All right, so constructors. Constructors are like special methods that are always called when an object is instantiated. So constructors are most often used to set initial values or perform some setup for our object. So let's say we create an object and we need to set an initial value for that object. This is where we would use a constructor. So in Java, we would write our constructor as a method with the same exact name as our class. So if we have a class called dog, our constructor would have to be called dog as well. That's how the JVM knows, hey, this is a constructor right here. A very important note about constructors is that constructors never ever have a return type. So do not specify a return type. So this is what sets constructors apart from methods. We said methods always have a return type, even if that type is void. Our method will always, we'd have to specify for the JVM, hey, this is exactly what this method is going to be returning. With constructors, we do not do this. Constructors do not have a return type because they're simply called when a object is instantiated. And when we instantiate an object, we're not going to be getting anything back. So we're just going to be creating that object, and that's what we're getting back. So we don't specify return type with constructors ever. All right, so a quick overview of the keyword final. So in Java, final indicates a variable that is only assigned once and is never changed. So we can use these for values that we know are never going to be different. So the final keyword is basically saying to the JVM, hey, this variable is final. It's not going to change ever. Do not allow it to be changed. If it's changed, throw up an error, and so the user knows, hey, you can't change this. One example of this would be, let's say we wrote in final double pi equals 3.14. So we know that the mathematical value of pi is never going to change. So this is a great use case of a final variable because we know pi is always going to be 3.14. We're not going to wake up one day and then suddenly pi is going to be 5. And we don't want our user to be able to change pi to be 5 or 6 or whatever. We always want pi to be 3.14. We can also use final to specify we do not want a class to ever be extended. So if we want a class to never have any children, we can specify that class as final, and then inheritance will not be allowed. So this is dealing with inheritance, so we'll talk about this more later. Final can also be used to specify we do not want a method to ever be overridden. So this applies to polymorphism. So if we have a method and we want to say, hey, never allow a method of the same name from an extended class to override this, then we can use the final keyword here. And this we'll get more into this when we talk about polymorphism. All right, so static keyword. So in Java, the keyword static indicates that a variable or method within a class does not belong to any specific object, but is instead a more general member of that class and can be executed without being tied to any object. So basically what this means is when we specify a variable or a method in a class is static, that means that that method or that variable doesn't apply to any specific class, but is generally we can use it. So we've already kind of used this. For example, main is a static method because we have our class, and within that class we create a static method main. And if we think about it, we don't actually instantiate an object of the class main exists in order to use main. We can just, our JVM will just find main and go to it and start executing main. It doesn't need to instantiate any objects. That's why main is static. So this is actually extremely common in Java. You're going to see the static keyword pretty much everywhere. This is because in Java, all code will be written within a class. And that means that, obviously we don't want to instantiate all our code as objects. So this is where static comes into play, and this is why you'll see static very commonly used. So as I just said, variables and methods can both be called static. You can even make classes static, but keep in mind this only applies if that class is enclosed within another class. So you can't have a top-level class specified as static. That isn't allowed. So it's important to recognize that with static, there are certain limitations to static members. So generally speaking, static members can only access other static members. And if we think about this, this makes a lot of sense why it's set up this way. Because non-static members are not general, they're tied to a specific object, whereas static members are general. So we can call static members without instantiating any objects. So if we were to call a static member and it tries to get information from a non-static member, how would that work? Because what if there were no objects instantiated? Then it's not going to be able to get any data. Or what if there's multiple objects instantiated? How will the static member know which information to get because you have multiple copies of the same information with different objects? So this is why if you have a static method, that static method can only access static members within that same class. You can't access a non-static member. Also keep in mind, static variables may only be instantiated once and only once to a starting value. So when you instantiate a static member, you instantiate it to a certain value, and then you can't instantiate it in multiple different objects. So I think I wrote this a little bit confusing. Static members are not final, so they can be changed, but they cannot be changed on an object-to-object basis, is what I'm trying to say. So if we create a static variable, we need to instantiate that in a general sense. So across all objects of a class, or even if we're not creating any objects, that static variable or that static member is going to be instantiated to a specific value. and then we can't change that on a class per class, or I'm sorry, on an object per object variable. So let's say we object per object basis. So let's say we have an object person, and then in our person class we have a static variable called like number of people or something like that. We can't have a number of people for each person. Number of people is going to be general across all people. How many are there? How many person objects are there? So that's something to keep in mind about static members in a class. All right, access modifiers. So as I said, public, private, and protected are access modifiers as they change which parts of a class we can access. So these are really important to understand and to utilize effectively because this allows us to keep our classes safe and make sure that our users are going to be using the class in the way we intend and that our class isn't going to break or anything like that. So any member in our class marked as private is only visible and modifiable within the context of that class and cannot be seen or changed within that class, outside of that class, such as in main. So if we have a class and then we have a private integer, we can't see that integer from main. We also can't try to change that integer. We're going to get an error. And then we also have the access modifier public, and any member marked as public can be freely modified and is visible from any other class, of course, assuming that class is imported or available in that context. So the reason we have access modifiers is because with access modifiers, we can limit or change how our classes are used. So if we have a part of our class that is integral to how the class functions and we do not want the user to be able to break it, we can identify this member as private. So let's say we're making a class or something, some kind of data structure, and we want the allocation parts of that to be uh, kind of protected. We want it to be private so the user can't access it because we want the allocation to be done by our class itself. We don't want the user to mess with it because if they mess with it, maybe they can break the data structure or we can lose a lot of data and that would be really bad. So in this case, we'd want to make sure to specify that those parts of our class are private so the user can't mess with them. All right, so we're going to get into some code now. So we will be creating a laundromat program. And in this laundromat program, we're going to be creating 3 different classes. We're going to create a store class, a person class, and a washing machine class. And functionality wise, we want to create washing machines and then we want to create patrons. So we want to instantiate these objects. And then we will go through each patron and they can choose to wash their clothes. We'll check if there's available machines, that kind of thing. But we will actually be doing this in the next video. So I hope this lesson was informative. If you would like to learn more about object-oriented programming in Java, you can check out our lessons at RouteFabric.com. Thank you.